This student book belongs to a set of student books which altogether provide a complete set of information to master SDMX. This student book looks at the different SDMX ML message formats, how they are built according to an XML schema file, and how to transform an SDMX ML message in another format. The standard messages used for data structure definition and structural and reference metadata structure definitions, and the different SDMX ML schemas defining the structure of the different SDMX messages. This video is based on the specifications of SDMX 2.0. The final part of this video highlights the major changes in SDMX 2.1 concerning SDMX ML messages. The SDMX 2.0 standard offers different XML formats for the exchange of data, structural and reference metadata, query messages querying the different messages from a web service, and registry messages for the interaction with an SDMX registry or repository service. A shared set of common XML message constructs was developed to be reused throughout all the SDMX ML formats. This includes a common header structure and basic common message structure parts for all SDMX ML messages. These shared common elements are implemented with the following XML schemas: SDMX message.xsd, representing common message construction rules including the header information; SDMX common.xsd, containing common low-level components to implement the basic structure. The XML namespaces provide uniquely named elements and attributes in an XML document. The SDMX message.xsd, implemented in relation with the message namespace, is the schema used for validating all SDMX ML messages. Other namespaces, such as the SDMX common.xsd, are imported by this schema. For a SDMX ML structure message containing a DSD, the structure namespace must be included. The SDMX standard includes a set of XML schemas. The specific schemas are importing the core schemas SDMX message and SDMX common to avoid redundancy. In some cases, the schema file is already fixed in the SDMX standards, for example the generic data message schema. In other cases, the schema is derived from the specific data structure definition message where it depends on. This is the case for the compact, utility, and cross-sectional data messages. A common part for each SDMX ML message is the header element, which has the same basic structure for all message types. Here is a typical header information of an SDMX ML data message on the transmitted dataset. Since all the messages are built on the underlying consistent SDMX information model, the 4 SDMX ML data messages can be converted to other formats. However, performing a conversion into a generic, compact, or utility data message requires some preconditions, such as the availability of the time dimension, frequency, and time format in the DSD. The data structure definition, as being stored in the SDMX ML structure definition message, represents the basis for the derived SDMX ML data message format schemas. These schemas rule the structure and content of the underlying SDMX ML data messages in the same format. SDMX tools and software that support both transformations and conversions between the different SDMX message formats are available on the sdmx.org website for free. We will now go into detail for the three most used messages: generic, compact, and cross-sectional. The characteristics of the generic SDMXML format are the following. It is independent of a data structure definition message. It includes the data structure. It provides a detailed understanding of the dataset structure for applications receiving the data. It allows the transmission of partial and whole datasets. All key values of the key dimensions are specified at the series level, and the SDMX attribute values are attached at a level defined in the underlying DSD. It does not provide for strict validation between the datasets and its structural definition. And it is not intended as a concise format to be used for large volumes of data. The data in generic format consist of 4 different levels in a nested arrangement. These levels, which are actually XML elements viewed from the outer to the inner, are dataset, which is the container of the dataset information. Group. One group element is defined for each SDMX group key. It includes all SDMX attributes attached to a particular group. Series. One series element per key is defined and includes the SDMX attributes attached at the series level. Series elements include, in addition, ops elements that represent the actual time-related measurements reported. Ops. One ops element per observation is included in each series. Each ops element contains all SDMX attributes attached at the observation level, the time of observation and the observation value. The generic format is a self-descriptive message. The XML elements, dataset, group, series, ops, attributes, and the XML attributes, concept, value, included in this generic message can be understood and interpreted independently from the DSD. The characteristics of the compact SDMXML format are the following. It is an efficient and concise format for exchanging large datasets. It is specific to and dependent on the data structure definition of the dataset. It follows mappings between constructs in the structure definition message and the compact format. It allows transmission of partial datasets and whole datasets. In terms of XML syntax, all codes and observation values are attributes. The permissible values of the codes are defined in the schema. A generic XML parser can be used to validate a data file against its structural definition. For the compact format, key values can also be defined at group level. The layout of the compact format adopts a 3-level nesting of XML elements within the dataset element. The groups are at the same level as the series within the dataset element. In the series element, the XML attributes holding the SDMX dimensions and all SDMX attributes are attached at the series level. Here, the SDMX dimensions form the key of the series. All observations are represented by the ops elements within the series element. Within the ops element, the SDMX time dimension, observation values, and attributes attached at observation level are included as XML attributes. In the top declarations of the SDMXML compact data message, a DSD-specific compact schema, in the example Eurostat STS compact.xsd, is included in order to enable syntactical validation of the message. The characteristics of the cross-sectional SDMX-ML format are the following. The cross-sectional message is specific to and dependent on the data structure definition of the dataset. It contains multiple observation values for different cross-sectional measures. It is the only format capable of expressing non-time series data structures. Key values are found from the group down to the observation level. In the top declarations of this message, a DSD-specific cross-sectional XSD has to be included in order to enable syntactical validation of the message. The group element is independent of the groups included in the DSD. The section element replaces the series element in the sense that it does not include a time series, but a section representing a vertical slice across several time series. The observation values are now included at the fourth level in DSD-specific cross-sectional measures. The DSD dimensions and attributes can be attached to any of the four levels according to the definition in the related DSD. The cross-sectional data message is applied for reporting datasets, including multiple measures and/or the exchange of data not organized in time series. The SDMX standard includes also other message formats. The SDMX ML structure definition message contains a data structure definition with or without reference artifacts, generally concept schemas and code lists. The query message is used to interact with web services and database-driven applications. There are three SDMX message types for reference metadata. Structure message, that contains the metadata structure definition. Generic metadata message, that contains reported metadata in an XML format which supports any metadata structure definition. Metadata report message, that contains a metadata report which is specific to a particular MSD. This format allows for the validation of the codes and structures described in the metadata structure definition with a generic XML parser. The core message structures and the special purpose messages for querying or registry services are defined by the following set of DSD, MSD independent standard schemas. For generic exchange of reference metadata, only the SDMX structure message and the SDMX generic metadata message are required. Other schemas are specific to and dependent on data structure definitions and metadata structure definitions, and therefore there is no single schema for all types of data to be exchanged. In these cases, standard transformations with dedicated transformation files such as XSL and XSLT are provided, and the schemas can be predicted from an examination of the related SDMX ML structure messages, DSD or MSD files. For all DSD-specific schemas, compact, cross-sectional, and utility, the SDMX standard provides a namespace to be used as the extension base for DSD schemas of that type. It will use the target namespace attribute. Other XML namespace attributes may be added if needed. Now, let's see the major changes in SDMX 2.1 concerning the SDMX ML messages. In general, the formats can be generic or specific to a data structure definition. The representation can be cross-sectional or time series. In SDMX 2.0, there were 4 distinct data message formats. In version 2.1, 2 message types were created, one generic and one structure-specific. Those cover now cross-sectional as well as time series representations. For backwards compatibility, time series variants have been defined based on the same structure. Some changes have also been made for the reference metadata messages. The structure-specific metadata set, previously called metadata report, is renamed to structure-specific metadata to be more consistent with the data messages. The XML structures of the generic and structured metadata sets have also been aligned. In version 2.0, the generic metadata message was structured much differently from the structure-specific metadata message. In version 2.1, the 2 formats are quite similar, with the same tags being used for each level of the metadata set structure, and there is a better equivalence between data messages and metadata messages. Concerning the technical changes to the SDMX ML schemas, the XML message schemas have been restructured to be closer to the information model, which also simplifies software implementation. In order to ease the maintenance effort and readability of the schemas, they have been broken into module files at appropriate levels. Each namespace contains a root schema, which includes the necessary modules, so that there is still a single point of entry for any given namespace. Note that the new structure of the schemas do not have a major impact on the structure of the respective XML messages. SDMX is sponsored by 7 international organizations since 2001. If you want to know more about it, look at sdmx.org, which provides the technical standard and guidelines. And also links to other resources, such as the SDMX InfoSpace and self-learning tutorials on specific topics.